Hello, myself Mohammad Rafi. I am from Anna Sahib Dange College of Engineering and Technology, Asta. Now I will discuss about reliability analysis of mixed configuration. So this is the introduction of reliability analysis of mixed configuration. In that we see a system is said to be a mixed system if the component of the systems are connected both in series or in parallel configuration. The reliability block diagram shown in figure next 14.5 correspond to a mixed systems where component 1, 2, 3 and 4, 5 are separately connected in series, while the two subsystems, one consisting the component 1, 2, 3 and another consisting the components 4, 5 themselves are in parallel. To evaluate the reliability of a mixed system, we first break the reliability block diagram into series or parallel subsystems. Then we evaluate the reliability of each subsystems. Finally, we evaluate the reliability of the given mixed system by combining the reliability of the subsystems and apply appropriate probability laws. The procedure is explained below with the help of an example. So this is the example. In that we see how the mix configuration will be done. So example is evaluate the reliability of the system for which the reliability block diagram is shown in figure below for a mission of 100 hour. Assume that all components are independent and the reliability of each component is given for a mission of 100 hours as follows. So R1 is 0.8, R2 is 0.75, R3 is 0.5, R4 is 0.65, R5 is 0.76, R6 is 0.6, R7 is 0.95, R8 is 0.90, where Ri denote the reliability of the component. I is equal to 1, 2, 3 to 8. So this is the reliability block diagram. So we see how the numerical will be solved. So the component of the given systems are connected in both series and parallel configuration. So it makes systems. To evaluate the reliability of this mixed system, we have to break the system into subsystem such that all component of subsystems are either in series or in parallel. This can be done as follow. So we perform some reductions. First reduction is combine the component 2, 3, 4 in parallel configuration to form an equivalent component 9. We see in next slide, see reduction in figure 14.11. So next reduction is combine the component 5 and 6 in parallel configuration to form an equivalent component make 10. And then third reduction is combine the component 1 and 9, 10 in series configuration to form an equivalent component 11. Then fourth reduction is combine the component 7, 8 in series configuration to form an equivalent component 12. Then last reduction is finally combine the component 11 and 12 in parallel configuration to form an equivalent component 13. The component 13 represent the complete system. The step-by-step reduction process is shown in this figure. So we see first reduction, second reduction, third reduction, fourth reduction and fifth reduction. So we are given that R1, R2, R3, R4, R5, R6, R7, R8 values are given in questions, where Ri denote the reliability of the given system or given component and I is from 1 to 8. Similarly, if R9 to R13 denote the reliability of the equivalent component 9 to 13, then using equations 8b and 4a we have. So component 2, 3, 4 are in parallel configuration. So R9 is 1 minus bracket 1 minus R2 bracket 1 minus R3 bracket close bracket 1 minus R4. So R9 becomes 0.9562. Then next we find R10. So R5 and R6 are in parallel configuration. So 1 minus bracket 1 minus R5 bracket close bracket 1 minus R6 bracket close. So this is the formula of to find R10 when the component are in parallel configuration. So next we see R11. So R1, R9 and R10 are in series configuration. So we simply find these equations by multiplying all the digit, such as R1 multiply R9 multiply R10, and it become 0.6915. Then we find R12. So R12 is equal to R7 and R8. So R7 and R8 are in series configuration. So in that, again we simply multiply both of them, and then we get 0.855. Then next is R13. R13 is equal to 1 minus bracket 1 minus R11 bracket close bracket 1 minus R12 bracket close. So this is the formula to find R11 and R12 when they are in parallel configuration. So R13 becomes 0.9553. Hence the reliability of the given mix system is 0.9553. Thank you.